In this video, we will compute the volume of a region in spherical coordinates. So the region here is inside of a sphere and between two cones. So it looks something like this. Here's the one cone, and here's another cone, and where it intersects the sphere, and we're looking at this region in between the two. So something like that. Now before we get started, it's important that we're able to write the equation for these cones in spherical coordinates. So before we actually do the computation, let's do that. So in general, the equation for a cone, at least in the form that we're given here, is like this. Z equals some constant, which I'll just write as a, times the square root of x squared plus y squared. Now I want to rewrite this in spherical coordinates. So let's substitute everything. Z in spherical coordinates is rho cosine phi. And x is rho sine phi cosine theta, and it's squared. And y is rho sine phi sine theta, and y is squared. And we can simplify this. Right, notice that in both terms we have rho squared sine squared phi, which we can factor out. And what's left is cosine squared theta plus sine squared theta, which is just 1. And then the square root cancels the squared. So this is just a times rho sine of phi. And there's a rho on both sides, which we can cancel. And now if we divide both sides by cosine phi and divide both sides by a, we get 1 over a is the tangent of phi. And so this is the equation. A cone, given in this original form, can be written in spherical coordinates as the tangent of the angle phi is equal to 1 over a. So these two cones that were given in the beginning of the problem, we can see that the first one, we have a equals the square root of 3, and in this second one, a is equal to 1 over the square root of 3. So the first cone, the equation is tangent of phi equals 1 over the square root of 3. And that will be the angle 30 degrees, which is pi over 6. And for the second cone, a is 1 over root 3, so tangent of phi is just square root of 3. And that's going to be the angle 60 degrees, which is pi over 3. Okay, now we can actually do the computation. So the volume, as always, is just the integral over the region of the function 1. And now we convert this into spherical coordinates. dv becomes rho squared sine of phi, d rho d theta d phi. And the bounds now. Rho goes from 0 to 1 because it's inside the unit sphere. Theta goes all the way around, 0 to 2 pi. And these last bounds for phi are what we just found. It goes from pi over 6 to pi over 3. So first, if we do the rho integral of rho squared is 1/3 rho cubed. From 0 to 1, that's just 1/3. And there is no theta in this function, so we just get a factor of 2 pi for doing the next integral. And so finally we're just integrating the sine function, which gives minus cosine. From pi over 6 to pi over 3. So I'm going to get rid of the minus sign by just doing the subtraction in the opposite order. So again, I'm not writing the minus sign, but I'm going to write this subtraction backwards. I'm going to plug in pi over 6 first, minus when phi is pi over 3. So cosine of pi over 6 is 1/2. Sorry, square root of 3 over 2. And cosine of pi over 3 is 1/2. And we can factor out the 1/2. Cancel that 2. And there we have it.